The National Electrical Code, or NEC, sets standards for electrical safety and installation. A common question arises regarding the appropriate breaker size for a given wire gauge. Specifically, the scenario of using a 35 amp breaker with a #10 wire is addressed. According to NEC section 240.4d, the overcurrent protection, such as a circuit breaker, must be sized according to the ampacity of the conductors it protects. This means the breaker's trip rating should not exceed the wire's safe current carrying capacity. For a #10 copper wire, the maximum allowed overcurrent protection is typically 30 amps. This requirement is in place to prevent the wire from overheating due to excessive current flow, which could lead to insulation damage and potentially a fire hazard. The code specifies this limitation to ensure the wire is adequately protected. Some exceptions to the general rule in 240.4d exist. These exceptions are outlined in sections 240.4e through 240.4g. Section 240.4e addresses tap conductors. These are short runs of smaller gauge wire used in specific applications where certain conditions are met, allowing them to be protected by a larger overcurrent device. However, tap conductor rules have very specific requirements regarding length, ampacity relative to the upstream protection, and installation methods. They are not applicable in general circuit wiring. Section 240.4f covers fixture wires and flexible cords. These types of conductors, often used in lighting fixtures and portable appliances, are permitted to have overcurrent protection exceeding their ampacity under very controlled circumstances, as the risk of overload and short circuits is lower in these specific applications. These specific applications do not extend to general circuit wiring. Section 240.4g refers to specific motor applications covered in Article 430 and air conditioning and refrigeration equipment in Article 440. These articles provide specific rules for overcurrent protection that sometimes allow for larger breakers than the wire ampacity would normally dictate. This accommodation accounts for the inrush current motors experienced during startup. Motor circuits often have unique requirements for overcurrent protection. The NEC permits the use of inverse time circuit breakers or fuses sized to accommodate the motor's starting current, which can be several times higher than the motor's running current. However, even under Article 430, the overcurrent protection is primarily intended to protect the motor itself from overloads and short circuits, not necessarily the branch circuit conductors. Therefore, the allowance for larger breakers typically doesn't extend to using a 35 amp breaker on a #10 wire in a general purpose circuit. Article 440 deals with air conditioning and refrigeration equipment. Similar to motor circuits, these appliances often have specific overcurrent protection requirements to handle starting currents and protect the equipment. Article 440, Parts Roman 3 and VI, specifically address the rating and selection of overcurrent protection for air conditioning and refrigeration equipment. These parts outline the considerations for determining the appropriate breaker or fuse size, taking into account the equipment's nameplate ratings, locked rotor current, and other factors. The NEC provides specific tables and guidelines for calculating the maximum allowable overcurrent protection for these types of equipment. However, Article 440 does not override the general rule regarding conductor ampacity. If the equipment requires a 35 amp breaker, the branch circuit conductors must have an ampacity sufficient to handle that current. In almost all cases, a #10 wire would not be suitable for a 35 amp breaker, even in air conditioning or refrigeration applications. If the full load amps, or FLA, listed as 17.8 amps and the maximum breaker size is 35 amps, the appropriate wire size must be determined based on the breaker size, in this case 35 amps. Since a #10 wire is only rated for 30 amps, it would not be suitable. The code does not have any allowances to use a #10 wire on a 35 amp breaker. If such a condition existed, it would violate the NEC, potentially creating a dangerous situation. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect conductors from overloads and short circuits. When the current flowing through a conductor exceeds its ampacity, the conductor will overheat, potentially damaging the insulation and creating a fire hazard. The overcurrent protection device interrupts the flow of current when it reaches a certain level, preventing the conductor from overheating. The NEC specifies the maximum allowable overcurrent protection for various conductor sizes to ensure that the conductors are adequately protected. The ampacity of a conductor depends on several factors, including its size, material, insulation type, and installation conditions. Larger conductors have a higher ampacity than smaller conductors. Copper conductors generally have a higher ampacity than aluminum conductors. The insulation type also affects the ampacity, with some insulation types being able to withstand higher temperatures than others. The installation conditions, such as whether the conductor is installed in conduit or free air, also affect the ampacity. The NEC provides tables that list the ampacities of various conductors under different conditions. These tables are used to determine the appropriate conductor size for a given application. It is important to note that the ampacity of a conductor is not the same as its allowable ampacity. The allowable ampacity is the maximum current that a conductor can carry continuously under specific conditions. The NEC provides rules for dirting conductors under certain conditions, such as when multiple conductors are installed in the same conduit or when the ambient temperature is high. Dirting reduces the allowable ampacity of the conductor to prevent it from overheating. In summary, the NEC generally does not permit the use of a 35 amp breaker on a #10 wire. The maximum breaker size for a #10 wire is typically 30 amps, as specified in NEC section 240.4d. Exceptions to this rule exist for tap conductors, fixture wires, flexible cords, and certain motor and air conditioning/refrigeration applications. However, these exceptions are very specific and do not generally apply to general-purpose circuits. It is always important to consult the NEC and any applicable local codes to ensure that electrical installations comply with all requirements. When dealing with electrical wiring and overcurrent protection, always prioritize safety. If there is any doubt about the correct wire size or breaker size to use, consult with a qualified electrician. They can assess the specific application and ensure that the wiring is installed safely and in accordance with the NEC. Attempting to use a 35 amp breaker with a #10 wire can lead to dangerous overheating. This could result in insulation breakdown, arc faults, and potentially a fire. Ignoring these rules places properties and lives at risk. If a circuit requires a 35 amp breaker, the wiring must be upgraded to a size that can safely handle that level of current. This generally means using a #8 copper wire or a larger size, depending on the specific installation conditions and conductor type. Always consult the NEC ampacity tables to determine the appropriate wire size for the intended application and overcurrent protection. In conclusion, while there might be exceptions and specific use cases within the NEC, a general-purpose circuit using a #10 wire cannot be protected by a 35 amp breaker. The code prioritizes safety, ensuring the wire's ampacity matches the breaker's capacity. Always adhere to the NEC guidelines and consult with qualified professionals for safe and compliant electrical installations.